Hello viewers, welcome back to my channel. This is the second lecture of the topic laser under the chapter Optics of MAKAUT B Physics syllabus paper code PH101 or 201. Students of any other university or any other institution may also follow these lectures to prepare for their semester physics paper. Before starting the video, if you have not still subscribed the channel, then please subscribe the channel and if you like my videos and video lectures, then please like those videos and share with others. And if you want to join my online classes, then you may contact me through the WhatsApp number given in the screen, and also you may contact through the Instagram and Facebook pages. So without wasting time, let us start today's class. In my previous lecture, I have discussed about what is population inversion and how can we achieve population inversion, what are the metastable states, what is light amplification, and what is the minimum number of energy levels that is required to produce laser. The link of my previous video of laser has been given in the description section. In today's class, I will start with how to construct a laser or what are the main components that a laser requires. The first component is a gain medium or a laser medium or an active medium. It is also called an active medium. The প্রথম কম্পোনেন্টটা হলো একটা gain medium, যাকে বলা হয় gain medium or laser medium or active medium medium. Now, as we know, first and foremost condition to produce laser, that is presence of population inversion or occurrence of population inversion, and for that population inversion we need a metastable state. So a medium that we require to produce laser that should have the properties like the population inversion phenomena should occur within it and presence of metastable state should be there. So an active medium means a medium which when excited reaches to a state of population inversion and promotes stimulated emission leading to light amplification. মানে কি একটা অ্যাক্টিভ মিডিয়াম বা গেইন মিডিয়াম যেটাই আমরা বলি না কেন, তার কি প্রপার্টি থাকতে হবে, যে যখন এটাকে এক্সাইট করা হবে টু রিচ এক্সাইটেড স্টেটস, ইট উইল রিচ এ স্টেট অফ পপুলেশন ইনভার্সন, তার মানে এর মধ্যে পপুলেশন ইনভার্সন মেকানিজমটা হতে হবে, and it will promote stimulated emission leading to light amplification. That means three processes may occur. Three processes should occur within it, that is population inversion, promotion of population inversion, stimulated emission, and that will lead to light amplification. So that type of medium is called gain medium or active medium. Second component is called a pumping source or normally called pumping. To attain population inversion, we have to provide an external pumping energy which will help to attain the ground level atoms or molecules to reach excited states and to reach the condition of population inversion. So an external amount of energy that we have to provide to the system or to the gain medium. And that process of applying enough energy to that active medium or gain medium is done by a process called pumping. So pumping is to attain and maintain population inversion condition, atoms of the lower energy level must be raised to excited levels by supplying enough amount of energy. And the process of supplying this energy to active medium is called pumping. So pumping can be of different types. Number one of the type is called optical pumping. Optical pumping means pumping is done optically. For example, flash lamp and high energy light sources. So optical, this is the optical pumping where যেখানে ইউজ করা হয় ফ্ল্যাশ ল্যাম্প অথবা হাই এনার্জি কোনো লাইট সোর্স. ফর এক্সাম্পল অপটিক্যাল পাম্পিং ইজ ইউজড ইন কেস অফ রুবি লেজার. That I will discuss the mechanism of ruby laser in next video. Second type of pumping is called electrical pumping. Electrical pumping means we have to apply a potential voltage difference or potential difference across the lasing medium. Then the pumping process is called the electrical pumping. For example, helium neon laser. The mechanism of helium neon laser that I will discuss in the next video. The third type of pumping is called in case of semiconductors. So in case of semiconductor lasers, movement of electrons and holes within the junction or the depletion region also produce pumping. So in case of semiconductor laser, movement of electrons and holes in the junction is done. That is the process which is called pumping in semiconductors. So these are the mainly three types of pumpings which are significant to produce laser in lasing medium. And third component to construct a laser is called optical resonator, and this came as a question in 2020 MAKAUT physics paper. The question was, write down a short note about optical resonator. Third component of laser to form or construct a laser is called optical resonator. এটা 2023 এর physics paper as physics semester question paper as a question এসেছিল, write down a short note about optical resonator. Now the three essential sufficient condition to produce laser within a material or to make a material to produce laser, the material should satisfy three necessary sufficient conditions. Number one is population inversion should occur within the material. What are the population inversion that I have discussed in my previous video? Second condition, that the laser or that the gain medium or active medium or the material which we are trying to produce laser should maintain, that is presence of metastable state. So to reach population inversion condition, metastable state is one of the important condition that should be satisfied. So metastable states should be present within that active medium or gain medium. So this is the second condition. And third condition to produce laser from an active medium is the external energy density or the incident radiation energy density that I have discussed in my previous lecture, that is denoted as U in bracket frequency, angular frequency omega, that U omega should be very much high. That means external radiation energy density should be very much high, so that probability of stimulated emission will be very much greater than the probability of spontaneous emission. That means probability of stimulated emission ta predominant hoye jabe over the probability of spontaneous emission. If these three conditions are satisfied by a material, then that material will produce laser or laser action we can observe within that material. So this is the three requirements for a medium to produce laser radiation, that is presence of metastable state, population inversion and energy density U omega corresponding to the laser radiation should be very much high, so that probability of stimulated emission should be very much greater than probability of spontaneous emission. Because in my previous video I have shown that probability of stimulated emission to the ratio of probability of stimulated emission to spontaneous emission that depends on external energy density or external radiation energy density. So that is incident radiation energy density. So these three conditions should be satisfied by that active medium to produce laser radiation. Then that medium, after satisfying all these three conditions, that medium will act or behave like a light amplifier. That means stimulated emitted photons will be added to the incident radiation and it will amplify the light. So after satisfying these three conditions, the material or the medium or the active medium will act as a light amplifier. Now to produce a laser source, we need that material to behave like an oscillator. That means a source of laser. Now the active medium or the gain medium can be transformed into an oscillator by providing a positive optical feedback to it, and it is done by placing the medium between two optically parallel reflecting mirrors M1 and M2 having properties where M1 has a reflectivity of 100% and M2 has a reflectivity of 90%. So that active medium is placed within two optically plane parallel mirrors M1 and M2. So these are two mirrors and active medium is placed in between them. So stimulated emitted photons which are generated within this active medium, that will be reflected back and forth within this setup or within these two optically plane mirrors. So stimulated emitted photons will be reflected back and forth within this system or setup. So more photons will be trapped within this chamber. As a result of that, a positive optical feedback is provided to it and the radiation energy density U omega should be very much higher. তাহলে কি হবে, যে লেজিং মিডিয়াম বা অ্যাক্টিভ মিডিয়ামকে আমরা একটা সেটআপের মধ্যে প্লেস করব যেখানে দুটো প্যারালাল অপটিক্যাল মিরার্স M1 and M2 যাদের রিফ্লেক্টিভিটি হচ্ছে 100% M1 এর and reflectivity 90% for M2. তার ফলে কি হবে, within that medium stimulated emitted photons will be generated that will be reflected back and forth from those two reflecting surfaces or reflecting mirrors. So they will be trapped within this setup. As a result of that, the energy density of radiation U omega that would be very much higher. So consequently a positive optical feedback has been provided to the system or to the active medium, which in turn will produce sustained stimulated emission, and the setup with the lasing medium will act as a source of laser or as an oscillator, and this setup is called optical resonator. So this is the short note about optical resonator. Next we will discuss about different levels of laser based on their number of energy levels. So minimum number of energy levels to produce laser that I have already discussed in my previous video, that is required is 3. So 3 levels are required at least to produce laser within a material. First we will discuss about 3 level laser system. So this is the diagram for 3 level laser, energy diagram for 3 level laser. So it consists of 3 levels. One is ground level E1, another one is excited level E3, and in between E1 and E3 one metastable state will be there, that is denoted as E2. So E2 is metastable state energy level. So initially the atoms at the ground level would be excited by a pumping process and they will reach at E3 energy level, which has a lifetime of 10 to the power minus 8 seconds. That means very short lived lifetime. So from E3 metastable state, which has a lifetime of 10 to the power minus 3 second, they will decay to the intermediate metastable state from E3 to E2. So E3 has a lifetime of 10 to the power minus 8 second, and E2 has a lifetime, metastable state has a lifetime 10 to the power minus 3 second. So it will reside, the atoms will reside here for a longer period of time, and population inversion will occur between level E2 and E1. So from E2 to E1 laser transition will take place. So this is laser transition. So a lasing energy levels would be from E2 to E1. So pumping frequency here is omega p, denoted by omega p would be energy level E3 minus E1 divided by h cut. Lasing frequency would be omega L, that is denoted by energy level E2 difference E2 minus E1 divided by h cut. Population inversion is occurring at level E2. So this is the frequency of laser, this is the frequency of pumping. So Wp is E3 minus E1 by h cut, omega L is E2 minus E1 by h cut. So this is the 3 level laser system. Example for 3 level laser system is ruby laser. Next we will discuss about 4 level laser system. Any laser material or system where more than 3 levels are present, they are called 4 level laser system. That doesn't mean that it will consist only 4 levels. It may consist of more than 3 levels, more than 4 level also. If the system consists of more than 3 energy level, then we will call that system 4 level laser system. এমন না যে ওটা 4টে লেভেলই হবে, হতে পারে 5টা লেভেল 6টা লেভেলের এনার্জি লেভেলের লেজার, বাট আমরা ওটাকে 4 level laser ডিনোট করব, as minimum energy level that is required for laser is 3 level. So apart from 3 level laser, all other laser systems having more than 3 energy levels, we call it as 4 level laser system. So this is the energy diagram for 4 level laser system. So this is the energy diagram for 4 level laser. So here this is the ground level, that is E1. This is the highest excited level, that is E4, we denote it. That uppermost metastable state, we denote it as E3. First excited level we denote it as E2. So here 4 levels are minimum 4 levels are present, E1, E2, E3 and E4, where E3 is the metastable state. So due to excitation or pumping, E1 atoms at the presence at E1 that will be reach E4, which has a very small lifetime, 10 to the power minus 8 second. So from E4 they will decay to E3, which is a metastable state or metastable energy level, which has a lifetime of 10 to the minus 3 second. So atoms will reside here for longer time, and population inversion will occur between E3, E3 and E2. So E3 to E2 transition will be radiative transition, and that is laser emission. So laser emission takes place between E3 to E2. Laser emission, and the frequency of the radiation frequency would be omega L, and that is equals to E3 minus E2 by H cut. So this is the mechanism for 4 level laser system. And example is 4 level laser system example is helium neon laser. Example is helium neon laser, which has a energy level more than 3. Now a very important question that comes, that is, what are the difference between 3 level laser and 4 level laser? Or question may come also like, which of the 3 level or 4 level laser require a higher pump power? That is also a part of the difference. So now in case of 3 level laser system, ground level of the laser system is lower lasing level. So high pump power is required for the atoms present at the ground level to reach the upper excited level. So high pump power is required for 3 level laser. So this is the diagram for 3 level laser. So in that lower lasing level is ground level. So this is the, in case of 3 level laser, ground state level is the lower lasing level. That means from metastable state this one to lower lasing level ground, which is ground level, lasing action taking place. So as this is the lower lasing level is the ground level, it requires, in case of 3 level laser, 3 level laser requires a very high pump power. But in case of 4 level laser, low pump power is required, because lower lasing level is not ground level. Lower lasing level is this first excited level. So this is the lower lasing level, and from a metastable state this one to first excited state, which is the lower lasing level, the lasing action is occurring. So population inversion, to create population inversion, low pump power is required in case of 4 level laser system. So first difference is, for 3 level laser system high pump power is required, and for 4 level system low pump power is required. Secondly, in case of 3 level laser, only when population inversion is occurring, then only laser is produced. That means the creation or the laser production is interrupted. Only when the population inversion is occurring, then only laser action will take place, or the lasing action will take place. So it is interrupted, means it is not continuous. But in case of 4 level laser, as the lower lasing level is not ground state level, so automatically population inversion will be maintained when we pump once. So in case of 4 level laser or 4 level laser, the continuously non-interrupted population inversion can be achieved, whereas in case of 3 level laser there will be interruption of population inversion. তার মানে কি 3 level লেজারের ক্ষেত্রে আমরা যখনই এক পাম্পিং করব সেই মুহূর্তেই কেবলমাত্র পপুলেশন ইনভার্সন হবে, এবং তখনই একমাত্র লেজার অ্যাকশন বা লেজিং অ্যাকশনটা পাওয়া যাবে, কিন্তু তার পর মুহূর্তে এটা বন্ধ হয়ে যাবে। তার মানে কি এটা ইন্টারাপ্টেড হচ্ছে। বাট ইন কেস অফ 4 level laser, as the lower lasing level is not ground level, so in between metastable and upper excited level, which is the lower lasing level, automatically after providing once pumping automatically population inversion would be maintained. তার মানে কি হবে, একবার পাম্পিং করে আমরা এটাকে নন ইন্টারাপশন পাবো, মানে ইন্টারাপ্টেড হবে না কোনোভাবে। সো নন ইন্টারাপ্টেড লেজিং অ্যাকশন আমরা 4 লেভেল সিস্টেম থেকে পাবো। সো দ্যাট ইজ দ্য ডিফারেন্স। অ্যাজ হাই পাম্প পাওয়ার ইজ রিকোয়ার্ড, দ্য এফিসিয়েন্সি অফ দ্য 3 level system is very much low compared to the 4 level system. So these are the differences between 3 level and 4 level lasing system. Questions comes like, sometimes it comes as straight question that write down the differences between 3 level and 4 level laser, or another way question may come like, which one of the 3 level and 4 level laser system is more efficient, or in which case of laser between 3 level and 4 level laser high pump power is required. So all can be answered from these differences between 3 level and 4 level laser system. So this is the end of today's lecture. Subscribe the channel and like these videos. If you like those videos, kindly share with others. See you in the next video. Till then, bye.